Hi everyone, this is Mesan and welcome to my channel Hassan Academy. Today we are going to discuss few more questions from this excellent book by MS Chouhan for advanced problem in organic chemistry JEE people. Okay, not only JEE, even NEET aspirant can go through easily level 1 and level 2 question from this book. You must go through, I believe, because there are a lot of different type of question you may get, and you will try to solve few of them or most of them, and you will get good knowledge from them. Because last year you can see NEET question was little bit harder side, so definitely you have to practice level 1 level 2 question from this book. Okay, I have it in the edition, and already we have discussed 10th question from this GOC chapter level 1. So I will start again from level question number 11. Okay, and whoever not watched that previous video, you go through there. This way you can from number 1 to all the question and up to level 3 you can go through one by one. Okay, any JEE needs JEE NEET aspirant watching this video, kindly share with your friend. See, this is very easy question. The functional group present in cortisone. Okay, cortisone structure and what are the different functional group? You can see here ether, CH2OH alcohol, ketone, again ketone, and C11C alkene. Okay, so alcohol, ketone, alkene and ether. So this is the correct answer. Without wasting time, let's go for further. B is the correct answer. Next, select the acid with the highest Ka and lowest pK below. I already said this in my previous video also. Acidity is directly proportional to Ka and acidity is inversely proportional to pKa. So if any one of these you can find out, you can find out the rest of the things. What they are asking, highest Ka or lowest pK. What is this? Acetic acid, and here two chlorine is there. Here again one cyclohexane and iodine and chlorine. If you see very nicely, you will get to know that here chlorine will show minus I, but it is far away. It may show little minus I, but it is also very far away. Here only CH3 group, but here two chlorine is there. So due to this one will be the strongest acid among all of this. Since it is strongest acid, so it will have highest Ka or lowest pK. So B is the correct answer. Hope you got it. How you have to find out? Yes. Suppose now here two chlorine. If I make another compound where I remove this hydrogen and I put one more chlorine, then that will be more acidic than this one. Okay, inductive effect will keep adding more acid and more strong acid. Hope you got all this. Now go to question number 13. What they are asking, most stable carbocation among the following. So this A is 3 degree carbocation, C is primary, B is secondary, and D is 0 degree carbocation, CH3 plus. Okay, now for B, secondary is there, but you can see 3 plus 2, 5 number of alpha hydrogen. That means 5 times hyperconjugation is possible. But here how much? 3 plus 2, 5. 5 plus 2, 7. So 7 number of alpha hydrogen possible. So blindly don't go through that always 3 degree will be more than 2 degree. There is nothing like that. 3 degree is generally more. Why? Because they have more number of alpha hydrogen. So you can get more number of hyperconjugation. But if whoever is making this question, if they want to make any tricky and they give such kind of 3 degree carbocation where there is no alpha hydrogen at all, but if they give CH3 CH2 plus CH plus CH3, that means propyl in propane in middle of the carbon carbocation they make this way, you will get 6 alpha hydrogen, and that time B, I mean secondary will be more stable than the tertiary one. But here it's okay, it is 3 degree one is the most stable carbocation A. What I trying to explain, that don't go blindly, always 3 degree will be more. There is nothing like that. Where number of alpha hydrogen is more, hyperconjugation or more, or with respect to inductive effect, that will be more stable compared to the other one. Go to question number next 14. Arrange the following in increasing order of pKa. Increasing order of pKa means in which one will be the most acidic, that will be number 1, then less acidic, like that. Here if you see methyl sulfonic acid, definitely sulfonic acid is very strong acid. Then acetic acid also very strong, but sulfonic acid is more strong. Okay, if you forgot this type of things, how you'll remember that if you remove from here one proton, you will get the negative charge. That negative charge you can do the 2-time equivalent resonance. But here SO3H, if you remove this proton and negative charge, that you can resonance in 3 times equivalent structure you will get. Here only 2 times. Okay, so this one is more than this one. Then obviously methanol is very weak acid. Okay, if you go through pK, this one will be around minus 1.9 and this one will be 4.76 and this is 15.5. Okay, methanol 15.5. So X is the least one, then Y, then Z. Okay, most pK, least pK, then little bit higher, then highest pK, X, Y, Z. Okay, B is the correct answer. Let's go for next one. Which is the major product of the following reaction? Okay, what they have given, this is the structure they have given. Here is nitrogen, and HCl is given. Okay, from here H plus will be released. Obviously it is acidic in nature, proton will release, and that proton will be captured by lone pair of nitrogen. Here is also lone pair is there, here is also lone pair is there. Now you have to know one thing, that between these two nitrogen, which nitrogen is going to receive that proton. If you are able to derive that, then definitely you are going to get the correct answer. Now one thing you have to know, that lone pair is there, that is not everything. That lone pair should be available also. Okay, if I am talking about this above nitrogen lone pair, that lone pair is not available, because that is going to do the conjugation with this, that is able to do the conjugation with this pi bond. Okay, but if you see this nitrogen lone pair, it is 100% available, because it is not coming under any resonance, so it is freely available and it will take that proton. And they have mentioned 1 mole. Okay, they are very nice question. This one strictly mentioned 1 mole, so you have to know that where that 1 proton is going to. Okay, it will go to this nitrogen. Where is this nitrogen? Option number B. Okay, this is the correct answer. Hope you got it. So this type of conceptual things you should know, that only nitrogen lone pair having is not everything, that lone pair should be available also. Okay, let's go for next question. Question number 16. In the given pair, identify most acidic compound in A and B and most basic compound C and D. So between A and B, you have to find out which one is most acidic, and C and D, which one is most basic. This is one of the very nice question and frequently asking this type of question. Okay, if you see benzoic acid, and here you can see that orthomethyl benzoic acid. Okay, now here one thing you need to know, benzoic acid, if ortho position any bulky group coming, then due to that bulky group, some ortho effect is generating. Okay, that ortho effect name is SIR. Okay, what is the name of that ortho effect? That is called SIR, steric. Can you see? Yes. The carbocation I was telling before, this is one of the example. Okay, 6 alpha hydrogen, 0 alpha hydrogens, and obviously it is 3 degree, it is 2 degree, but even though it is 2 degree, it is more stable than this one. I will make separate video for that. What I was talking about, that ortho effect name SIR. Okay, one of the very important thing, SIR, steric inhibition of resonance. And due to this ortho effect, acidity of this benzoic group is increased, and this one number 2 is more acidic than the number 1. Okay, I will make detailed video what is SIR and in details. But now you just understand that benzoic acid ortho position any bulky group is present, then that benzoic acid showing some kind of phenomena that is called SIR, and due to SIR acidity is increased. So between 1 and 2 in number A, 2 is more acidic. Now come here 1 and 2. Okay, now you have to remember one thing, this SIR ortho effect steric inhibition of resonance, this thing only working with benzene ring. Okay, ring should be benzene, not cyclohexane. With cyclohexane, this concept is not going to be valid. And once it is cyclohexane, now this, if you remove this proton, it will get negative charge, and if you remove this proton, you will get negative charge, and this negative charge, due to this methyl plus I effect, it is less acidic, and 1 is more acidic. So in this case, due to ortho effect, number 2 is more acidic, right? But here you cannot use ortho effect. Here you need to see the inductive effect, and since it is plus I is decreasing the acidity. So here number 1 is more acidic. Okay, so what we are getting in case of number A, 2, in case of number B, 1. Okay, next go for number C. You can see here aniline and orthomethyl aniline. Okay, orthomethyl aniline, or in some other way also you can tell this one, orthotoluidine, like that also you can tell, but okay, orthomethyl aniline. Now what I can say here, that here also some SIR kind of phenomena is working here, okay, but here the effect is not named as SIR. This is called SIP. SIP. You can see menu, sorry, not SIR, SIP. You can see menu one directly telling ortho effect. It's all okay, or since it is they are in ortho position, so ortho effect telling is okay, but is specific name if you want to know, then that name is SIP. I will make detailed video how SIP decreasing the basicity, SIR increasing the acidity of benzoic acid, but SIP decreasing the basicity of aniline kind of structure, okay. Steric inhibition of protonation, full form, okay. Now you see here, number one, NH2 and nothing is there in ortho position, but number two, ortho position methyl is there. Now you have to remember one thing, if aniline kind of structure and ortho position some bulky group coming, now SIP is going to act here, and due to SIP basicity decrease, okay. Here due to SIR acidity was increasing, and here due to SIP basicity going to decrease, okay. Both ortho effect only, but their action is opposite here. So how it is basicity decrease, this thing I will discuss in later, because it will take a lot of time. I will make details video, but that much you know, due to ortho effect in case of aniline basicity decrease, so this one is less and one is more, so C is number one. C is number one. And then again go for option D. Option D, you can see instead of benzene ring they have given cyclohexane, and cyclohexane is not showing this all SIP SIR ortho effect. So obviously number two is more basic here, because this methyl group is going to give plus I. Due to plus I here uh, electron density increase, and it will make the basicity more. So D is again number two. So A to B1, can you see, right, A2 B1 C1 and D2, where it is there, it is there in option B, okay. Hope you got it. The option B is the correct answer, okay. So up to here only I have discussed today. Tomorrow I will start from question number 17, because it's already 12 minutes, otherwise video will be very lengthy. Hope you got it. And these two effect you remember, SIR and SIP. Due to SIR effect, in case of benzoic acid acidity increase, due to ortho effect, that is particularly mentioned SIP, and due to that basicity of aniline is going to decrease. Hope you got it. Thank you for watching, and keep sharing with your friend, and any doubt you can write in comment section, or you can email me any help you want, okay. Thank you for watching this video.